Hello, wonderful people. Here we are, chapter 34, electric current. We are on section 11. We're doing just one section today, and it's on power, power, power. So, electrical power is the power that delivered by electricity. And what is power? Power is a measure of work, how much work you do per second or per time. So if you have a little engine and it's just doing a little bit of work, it's going to take a long time to get that job done. But if you have a really big engine and it does a lot of work in a short amount of time, then it's more powerful. So that's what power is, a measure of how much energy you're spending per second. It doesn't have to be per second, but most of the time that's what we use. Okay, so that should be familiar to us because we had power back in like October when we were talking about mechanics. And we talked about horsepower. We even used the word watts. And there's lots of different measurements of power. But so we've seen this before. Now we're just going to talk about how electricity, which of course does lots of work for us, and how we measure electric power. Okay? Um, okay. Slide. Now, we've talked about power before. Do you remember when we talked about force and then we talked about energy and then power was the rate of energy. So a more powerful car can uses more energy so it pushes you down the road faster. Same idea with electric power. Power is the rate at which electrical energy is converted, it is used. Just leave it at that. So if your computer or your electric motor or your refrigerator is really powerful, then it's going to use a lot more electrical energy. And here's the formula, because it isn't physics if we don't have a formula. Electric power equals current times voltage. That's already in the notes. Um, and we measure power in watts. Now, when we were measuring power in the mechanics part of the course, we talked about horsepower and joules. Not joules per second is a, we did mention watts back then. So watts is a unit of power, and that's what we're going to use for electricity. And power is current times voltage. Okay, so that's electric power measured in watts, and power equals current times voltage. There's an example I'm not going to use, but I did want to point out that's an old-fashioned light bulb. I'm sure you've seen light bulbs like it. You might not have any in your house anymore. And right there it says on it, 60 watts. Um, skip that. Oh, here we go. A kilowatt is 1,000 watts, just like a kilometer is 1,000 meters. So kilowatt is a name that you have to know. And now we talk about a kilowatt hour. A kilowatt hour represents the amount of energy consumed in 1 hour at the rate of 1 kilowatt. And that's how electricity is priced. Where electrical energy costs 10 cents per kilowatt hour, a pretty average rate, a 100-watt light bulb burns for 10 hours for 10 cents. A 100-watt light bulb's a little powerful, but things like toasters or irons, they draw a lot more current, so they take more power, and therefore they cost a lot more to operate for the same time. So if you leave the lights on overnight, it's not the end of the world. But if you leave your iron on overnight, you're gonna see that in your electric bill. Just a buck or two, but that's why we make sure we turn things like the stoves and the irons off. How much power is used by a machine that operates on 8 volts and 1 amp? Power equals current times voltage. So 1 amp times 8 volts is 8 watts. The second question. If it's used for 1 hour, how much energy does it use? Energy equals power times time. So 8 watts times 1 hour equals 8 watt hours. oh, and then on the electric bill, they don't do it in watt hours, they do it in kilowatt hours. So you would see that on your electric bill as 0.008 kilowatt hours. Will a 1,200 watt hair dryer operate on a 120 volt line if the current is limited to 15 amps by a safety fuse? So, you 1,200 watt hair. That's more complicated than I wanted to get right here, right now. Yes, the answer is yes. Because, and here's what I will say: a 15 amp safety fuse means that 15 amps and 120 volts, you can have 1,800 watts coming out of that line, out of that plug. But if you try to get any more power out of it, then the safety fuse will trip. So that's why you can't have two hair dryers on the same plug operating at the same time. You will trip the breaker. Actually, what I said right there, I think you can handle that just fine. I was going to try to not talk about breakers until later this week, but what I said right there is fine. Okay, so that's the end of the lecture for the day. I'm going to take us through some review questions for the whole chapter, and then I'm going to, you know what, I'll just do the review questions here now for the whole chapter, and then I'm going to post a second video where I go over some of the homework problems to make sure that everybody can get through that okay. Okay? So we're going to, if you want to just end the lecture here, we're done. And if not, then we're going to go on to these questions.